2 more examples to finish up in lesson 1.7, and then we're officially done with the chapter even, as crazy as that sounds. Okay. Example 4. Okay, we're writing equations again to be able to solve stuff. A square is inscribed in a circle. Write the area of the square as a function of the radius r of the circle. So a square is inscribed in a circle, and our job is going to be to write the area of the square, but when we talk about area of the square, as a function of r. When we find the area of a square, do we usually talk about the radius? No, but that's the connection we're making. Okay, so let's draw a picture. A square inscribed inside a circle means what?
The square inside a circle.
Square inside a circle. Officially inscribed would mean that each vertex of the square is touching the circle, yes. Technical definition, whether we draw it that way. I'm trying to remember if I usually draw my square then my circle. I think I usually draw my circle first. Okay, not bad circle. I'll take it. And then, yeah, this is rough. Ooh. Oh, no, I can't do that. Let's try that again. I guess my circle is not exactly circular. Okay, we're going to pretend that that is a square inscribed inside a circle. Okay? Now, what do you normally think about finding the area of a square? For area, just length times width. But since we're specifically talking about a square, what do we know about length and width?
They're the same.
They're the same, yes. And so you'll often see area of a square written as s squared, where s stands for the side of a square. Okay? So that means this is a s, right? This is s. So side times side, side squared. Now, we have to somehow connect this to r. We have to take the s out of this equation and replace it with whatever it's equivalent to in terms of r. Okay? Where is the radius here?
Middle of the square.
Okay, radius goes from middle of the square, middle of the circle, whichever you want to call it, out to where?
What? Well, it starts.
To the side. To one side.
Goes to one side or another, right? Someplace on the circle. Now, I'm specifically going to draw a radius because the radius could be anywhere around the circle, yes? Doesn't have to be, there's not just one. I'm specifically going to draw my radius to this point. Why would I draw it to that point? Okay, that's a corner vertex of the square, yes? And so there's a connection that we can be made there. I could also draw another radius. I'm going to draw this radius as well. The picture's not looking very drawn to scale, but that's all right. Are you seeing any connection?
It's going to be the same. But they're all going to be the same, all the radiuses.
All your radiuses are going to be the same.
Would it be half the size of the square?
It's not half the size of us.
Like the side. One
Ours
side,
are
other
the
side.
same length as the.
The radius is not half the side of the square. Is that what you were asking? No, that's not that exact connection.
Would it be the same length?
No,
as the side?
it's not the same length. It's not a fourth. What I'm looking for here is kind of an equation that I can set up that would connect the radius and the side. What do those radiuses and sides make?
Oh.
We have a triangle there, yes? Now, think about this triangle. What kind of angle, and mine's not drawn the greatest, but what kind of angle would this have to be? 90? Again, mine's not drawn. Mine doesn't really look exactly 90, does it? But think with me here. I'm going to claim that this is supposed to be 90 because how many of those angles would be around the circle? There'd be 4, yes? And when you go around a circle, all the angles have to add up to be 360, and 4 90s is 360. So I'm going to claim that that is a 90-degree angle. That's a 90-degree angle. What equation can I set up here? What connects R, R, and S? What formula?
The
It is an isosceles triangle, but
1/2.
there might be a formula there, but I don't know. This is what type of triangle?
A right triangle.
Right triangle. What formula or equation always applies to the sides of a right triangle?
I would explain.
Oh, aren't they all the same?
No. It's a theorem.
Pythagorean.
Pythagorean theorem? It was not coming to you guys, sorry. I'm trying to give clues, it just was not there. I got it, okay. Monday morning, whatever. Okay, so this is a right triangle, folks. If you can identify a right triangle, Pythagorean theorem is what? Uh-huh. A squared plus B squared equals C squared. What are my A and B here? R's, because A and B are your legs that meet at a right angle. What meet at a right angle here is R and R. So R squared plus R squared equals, what's my hypotenuse, my C value? S. So I have R squared plus R squared equals S squared. What is R squared plus R squared? 1R squared plus 1R squared is 2R squared, equaling to S squared. We can think of this in two different ways. Officially, we're trying to replace S here, yes? So if you're just going for, okay, I need to solve for S to replace S, how do I take S squared and solve for S? You're going to square root, yes? And so if I square root, the idea is then the square root of S squared is S. The square root of 2R squared, well, the square root of 2 is square root of 2. We can't do anything with that. What's the square root of R squared? R. So you could write this as R times the square root of 2. Now, we know that S equals this. What can I do with this? Put it into your equation. So we already talked about area of a square being area times S squared, except that what do we know S is now? S is equal to R square root of 2. So we take R square root of 2 and square it. And then we're just squaring back what we just square rooted. When you take R and square it, you get R squared. When you take the square root of 2 and square it, you get 2. So 2R squared. And notice, folks, what did we have up here? We had actually found S squared equals 2R squared. You could have stopped right there and subbed at that point, but. Okay, so if you want to find the area of a circle, or excuse me, area of a square that's inscribed a circle, you can do 2 times the radius squared. You don't have to know the length of the side of the square. You just have to know the radius. Yes?
On the homework, are we going to be doing stuff like finding out like equations like this, or are we going to be using these equations? Like, are they going to give us stuff?
You're going to have to find some equations.
Okay.
Okay, so it's being able to look for, like here, you had to look for that Pythagorean theorem connection. I'm trying to think what else. When we started on Friday, it was area of a circle, and we had to, first we wrote it with radius, then we wrote it with diameter. So what's the connection between radius and diameter? Then we wrote it with circumference. So it's looking for the connections. That's what some of the homework will be, yes. So there'll probably be some formulas I'll have to help with. Or Google is always our friend when it comes to what's the area of a circle or something like that. Okay. Example 5. Maybe a needed break for our brains. I personally view example 5 as easier once you see how to set it up. A number added to 4 times that number is 450. What are the two numbers? Now, I'm the math teacher, so I could, but I'm not going to lead you guys to guess and check. We've been trying to write equations today, right? Or in this lesson. So think about an equation I could write here. For a number added to 4 times that number is 450. What do you think, Autumn?
X plus 4x equals.
Do you see it? A number. What do you want to call a number? Autumn says X. Added to plus 4 times that number? Well, if that number was X, 4 times that number is 4X, is 450. In other words, I like this one because if you catch the wording, can you just translate the words into math symbols? Okay. So you have the equation X plus 4X equals 450. How do we solve? Okay, yeah. 1x plus 4x is going to be 5x. If 5x equals 450, divide by 5, and we find x to be 90. Am I done? No, I said what are the two numbers?
Oh, that 4.
What's the other one?
4.
Not 4.
90.
No.
300.
Why 360?
Because 92.
Yeah. A number was one of them. 4 times that number is the other one. So what is 4 times x? Well, that's 4 times 90, which is 360. Okay. Your homework that goes with this is 1 through 16, 18, 19, and 21 to 23 in lesson 1-7, which is page 143. You have some work time. Okay. I'll be available to help. We may have to confer on equations that we don't remember, right?